Hello, I welcome you all. The problem reads block A weighs 10 pounds and block B weighs 3 pounds. If B is moving downwards with a velocity of 3 feet at t equal to 0, determine the velocity A when t is equal to 1. The coefficient of kinetic friction between the horizontal plane and the block is 0.15. This problem is coming from the Engineering Mechanics and Dynamics 14th edition by R.C. Hibbeler. So let's draw the free body diagram. Section there, with section there, with section there, and there we go. Okay, there we go, like so. All right, and then we have tension there, like so. Okay, and then there we go. Okay, and there we go. Okay, and there we go. All right, so there we go. We have drawn the free body diagram with the weight there, like so. Let's label this. This is WB. This is WA. This is NA. This is FK, which is just equal to mu A NA. So if this is T, this is T, the tension there, then this one becomes 2T. Alright, so if you look at this figure, we have two problems. There was case 1 and case 2, but I want us to check the value for case 1 so that we have a question. So let's look at case 1, what we found. So it's 15, case 1, which is 15-31. Okay, so here we found our VA2. Our VA2 is equal to 10.5. Okay, 10.49 feet per second. Our VB is equal to 5.25 feet per second, right? All right, so the question is, the only difference in the other case, in this case here, this was not there. Okay, then in here this was there. All right, get it? So the question is, what do you think would be the velocity of the other cases when friction is there? Will it increase or reduce? I guess you know the answer, right? I won't tell you. You can pause the video and guess. Okay, or predict. So let's go to our case 3.2 quickly. So let's also find the positions which will relate, and once we take the derivative it will give us the velocities, right? Remember this concept. Okay, there we go. So this is our SA, this is our SB. So we have SA plus 2SB is equal to L. Derivative, this just gives us this. And therefore VA is just equal to minus 2VB. Or you can think of VA as VA in this direction is equal to 2VB in this direction. Alright. So that is basically what we are saying. Okay. No hard stuff. It is just as plain as that. So then let's go to B. Now we are using linear momentum and linear impulse. Okay, M delta V for B. Alright, so we'll say WB minus 2T times delta T is just equal to M VB2 minus VB1. So we know that our WB is just equal to 3. Our delta T is equal to 1 minus 0, which is just equal to 1. Our M is just equal to 3 divided by 32.2. And our VB1 is just equal to 3. Therefore, this just becomes 3 minus 2T times 1. This is equal to 3 divided by 32.2. VB2 minus 3. Alright. Therefore, this just becomes VB2 is equal to 35.2. When we divide through there, it becomes a 21.46 T. Right? 21.46. Okay. Then we know that VB2 is just equal to VA2 divided by VA2 divided by 2. So if we are to plug in this there, this just becomes VB2 is equal to 70.4 times 21.47 by 2. We have a 42.94 T. Alright, then let's move on. Then using integral of f dt equal to m delta v for a so here there is friction, don't forget that. So it's T minus friction Fk times delta T equal to M VA2 minus VA1. Fk is just equal to mu A, which is just a 0.15 by Na. If Na itself is just Wa, and is equal to if we are to apply the summation of forces here quickly, the y equal to Ma, but we know that A is equal to 0. Okay, so summation of forces in the y equal to Ma, but we know that A is equal to 0. So we have Na minus Wa equal to 0. Therefore, Na is just equal to Wa, which is equal to 10. Okay, so this is just by 10, which is just equal to 1.5. Then we have Va1, which is just equal to 2 by Va1, and 2 by VB1. Okay, this is equal to 2 by 3, and this is just equal to 6. So we have T minus 1.5, and our delta T here also is equal to 1. Okay, by 1, T is equal to 10 divided by 32.2. Then we have VA2 minus 6. Alright, therefore our VA is just going to be equal to 3.22 T. Okay, 3.22 T, 1.5 divided by 10, 32.2. Okay, then plus 6. So we have plus 1.17. So we have these two equations. This one here, this one here is VA2. Okay, we are writing in terms of VA2. Alright, now these are the two equations. Mind you, we solved this similar one in the previous video. So solving equation 1, equation 1 and 2, we are going to have 70.4 minus 42.94t equal to 3.22t plus 1.17t. I mean just 1.7. Then t here is just going to be equal to 17.4 plus 1.17. Okay, 70.4 minus 1.17 divided by 42.94 plus 3.22. Okay, so we have 1.4998. So using one of these equations, so we have VA2 equal to 3.22t plus 1.17. Then we have VB2, which is equal to VA2 divided by 2. So if we are to feed this here, then we have the following. Well, our VA2 is just going to be equal to VA2 and VB2. So this becomes 3.22 times 1.4998 plus 1.17. So this becomes 6 feet per second, and half of that is just 3 feet per second. So these are the directions. This one is like so, and this one is like so. Right, I guess this is about it. And you've seen the velocities have reduced, and you expected such, right? Compare this with this, right? They have reduced because of friction there. Alright, so I hope this particular video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and sharing my video. Bye bye, and I'll see you in my next screencast.